In this lecture, you'll learn about wireless infrastructure mode and access points. And it really helps to understand how WLANs work if you understand the terminology from the 802.11 standard. So I'll be going through the standard terms in this lecture. Wireless access points provide connectivity between wireless stations and between the wireless and wired networks. And when your wireless devices are communicating through a wireless access point, they're operating in infrastructure mode. Wireless is half duplex, meaning only one device can communicate at a time. So in that regard, your wireless access points operate similarly to hubs. Here's a picture of a typical wireless access point from Cisco. Your wireless APs can have either internal or external antennas. You can see the one here is internal, and they can also be designed for indoor or outdoor use. Okay, first piece of terminology is BSS, the basic service set. So an access point centralizes access and control over a group of wireless devices. Those devices under wireless settings make up a BSS. You remember from the last lecture when we covered ad hoc mode, it was called an IBSS, an independent basic service set, because in that peer-to-peer network, the devices were operating independently without an access point. Well, now we do have an access point, so it's not independent anymore. It's just a BSS, basic service set. Next terminology is DS, the distribution system. So your wireless AP provides connectivity to the wired network for the wireless clients. And it's a distribution system that connects the wireless access points to the wired network. So in the example here, you can see our AP is connected to the switch here. That's where it's getting connectivity to the wired network. So the switch is known as a distribution system. BSS ID is a basic service set identifier. Devices within the basic service sets are identified by their BSS ID, and that is based on their MAC address. So you see the example here, our wireless AP has got MAC address A.B.C, so that is used as its BSS ID to identify it in the wireless network. BSA is a basic service area, and the BSA is the wireless coverage area of an access point. This is also known as a wireless cell. So you see the example here, we've got our AP in the middle, that is its basic service area, its area of coverage, that's the BSA. SSID is a service set identifier. The SSID is a unique identifier that names the wireless network, WLAN, for example, corporate. For sure, you've seen this before. If you've walked into any coffee shop and asked to get onto their wireless network, they will give you the SSID and the password to connect to. A single access point can support multiple SSIDs, for example, corporate and guest. And different SSIDs can have different security settings and be mapped to different VLANs. So, for example, in our corporate office, we have created a corporate SSID and a guest SSID. For users to be able to connect to the corporate WLAN, they need to supply a valid username and password. When they do that, they're mapped to the corporate VLAN and IP subnet, and they get connectivity to all of the internal corporate resources like servers. If a guest walks into the company and they want to get wireless access, they can get that too. They connect to the guest SSID. To do that, they only need to provide a password rather than be a valid user inside the company. But when they connect to the guest SSID, they're mapped to the guest VLAN and IP subnet, which does not have access to any internal resources. We just give them internet access. Beacons, wireless access points, broadcast information about their WLANs, including the SSID and authentication requirements with beacon frames. This can be disabled, which can give you a little bit of extra security because people cannot then easily see the SSID. However, it is trivially easy to sniff this information from other traffic in the wireless area and find out that information. ESS is an extended service set. The same SSID can be supported across multiple access points to give a larger coverage area. So you can see in our example here, we've got our corporate SSID, we've got a wireless AP on the left here, and it's got its coverage area, its BSA, and then we've got another wireless AP, which has got its coverage area, its BSA, and we can keep adding additional wireless APs in our building until we cover the entire area. Now, when you do that, you want wireless APs, which are neighboring each other, to be using different channels so they don't interfere with each other. I'll cover that in a lot more detail in a later lecture in this section. And finally, we have got roaming. Wireless client stations can roam across wireless APs supporting the same WLANs. So in our example here, we've got our laptop here, which is currently connected to the first AP. If you're on that laptop and you're wondering about the building with your laptop, then your laptop can roam to other APs like that. Okay, that was everything that I needed to cover here. In the next lecture, we'll talk about wireless LAN controllers, which give us more scalability again.